Fellow nerds, let's talk about the derivative of cosine. My approach to differentiating cosine is going to require that you at least remember a little bit of pre-calculus, specifically trigonometry, and including some of your Pythagorean identities, as well as you've already gone to my first video of this series and we've learned that differentiating sine does indeed give you cosine. So the derivative of sine is cosine, and of course a couple of the Pythagorean identities, and you should be scotch-free. But let me show you my approach to thinking about this. Again, this is not I would not think of this as a rigorous proof, but this is a really good way if you're just learning calculus to kind of connect the dots in terms of the derivative of cosine and how do we arrive at what its formula is. So without further ado, we have the derivative of cosine. Rather than go to the limit definition of cosine, the limit definition of a derivative, what I'm going to do is rethink of cosine itself. So if you remember, we already know the derivative of sine is cosine. So I want to take this cosine that you see and I want to convert it into a sine thing. And I can do that through the Pythagorean identity. So sine squared plus cosine squared is 1. So obviously if I subtract my sine squared over, and then of course if I raise both sides of that equation to the power of 1/2, or what most people think of as just square rooting, that's fine. But I'm going to leave it like that. So into this derivative we go. So I'm going to take that expression that we just got from the Pythagorean identity and insert it for cosine. So I want to differentiate this. So that being said, if you looked at that long enough, and again, if you're first kind of learning calculus, what I want you to see is what we have as a function, right, inside of another function. That's chain rule. And so specifically, what is our outside function, so to speak, right? So we have this thing to the power of 1/2, that's our outside. And of course, what's inside of that is 1 minus sine squared. So to do chain rule, my favorite way to do it, especially, again, this is really for those beginners of calculus, is let's break this apart into our outside function and our inside function. So our outside function's derivative is just a power rule. So let's bring the 1/2 down, subtract 1 from our exponent, and we get, of course, negative 1/2. But our inside function, I want to differentiate that, but got a kind of a problem, and it's that square on that sign right here. Well, if you remember what that is notation for, right, that's really notation for 1 minus, of course, the quantity sine of x squared. So how do we differentiate that inside function, so to speak? Well, guys, that's just another chain rule. So again, let's break this apart. Again, I'm doing this only for the beginners of calculus. So that would give you your outside function is 1 minus something squared, inside function sine. Here we go. The derivative of our outside function in this context would just bring the 2 down, subtract 1 from your exponent. You'll notice that this one disappeared. Remember, the derivative of a constant is 0. Going over to the derivative inside, remember, we already learned that the derivative of sine is cosine. So here we go. I want to come back over to here now. What is the derivative of this inside function in and of itself, right? So we had to do our chain rule. Here we go. So it's the derivative of our outside function. Leave your inside function alone times the derivative of your inside. And there it is. That is the derivative of this inside function. Now let's put it all together. All right, here we go. So the derivative of this composite function would be the derivative of its outside. Leave your inside function alone times the derivative of your inside. And so we get this nasty looking expression. Again, it's actually not that bad, because one thing you might notice, well, let's just clean it up for a second. So we don't really need this power to the 1/2 and maybe all this color. So let's kind of get rid of all of that. So you might notice that we have a multiplication of a 1/2. We also have a multiplication of a 2. And so those two things right there, when multiplied, obviously cancel out. And so we can actually just reduce this expression at least a little bit. The next thing that I want to do, a little strange, but it will make my algebra just a little easier, is we have this expression here times this expression here. And multiplication is commutative. It doesn't matter the order in which I multiply those. So let's actually flip the order. So now we're looking at this. Well, look at this negative exponent. Again, going back into algebra days of life, right? We understand that negative exponents translates to the reciprocal of that same power. So what I'm going to do is rewrite that entire 1 minus sine squared of x down in our denominator to the power of 1/2. And now looking at this, we've got something that's really lovely, right, we have this 1 minus sine squared x, which if you remember, we already talked about, that's cosine squared. So let's now replace the 1 minus sine squared here with a cosine squared. And look at that, we have cosine squared, but to the power of 1/2. And of course, if we raise a power to a power, we multiply. Guys, that's like saying square something, then square root. They cancel, and we're left with just cosine. And so guys, looking at this, we now have cosine of x times 1 over cosine of x, which again, that cleans up even further, right? Those cancel, and there it is. The derivative of cosine is actually just a negative sign. Take care, nerds.